Usually just differentiation, and it says given that y is equal to x cubed plus 2x squared minus 1, determine the coordinates of the stationary points. All right, so y is equal to x cubed plus 2x squared minus 1. And you're asked to determine the coordinates of the stationary points. Stationary points occur when dy by dx is 0. So we need to find dy by dx. dy by dx is 3x squared plus 4x. That's dy by dx. 3x squared plus 4x. Now set this equal to 0. Solving this for 0 now, if I factor out x, I'm going to have 3x plus 4. All right, so I have 3x plus 4, and this is equal to 0. So what does that mean? That means that x is equal to 0, or 3x plus 4 equals 0. Nice and easy. X equals 0, or 3x plus 4 equals 0. All right? Now, 3x plus 4 is equal to 0. What do? You transpose for x. And so x is equal to minus 4 over 3. Now that we get that x is minus 4 over 3, we can resubstitute it back into the original equation to find what is y. Substituting when x is 0, we're going to get y is negative 1. And then plugging in x as minus 4 over 3, we're going to get minus 4 over 3 squared plus 2 times minus 4 over 3 minus 4 over 3 cube plus 2 times minus 4 over 3 square minus 1. And so I get y is 5 over 27. So those are the two stationary points. So go ahead, tell them that those are the two stationary points. So the two stationary points are 0, minus 1, and negative 4 over 3, comma, 5 over 27. Those are the two stationary points. Next thing, again, determine the nature of their stationary points. To determine the nature of their stationary points, you need the second derivative. The second derivative, which is d2y by dx squared, second derivative is going to be equal to the 3x squared differentiated gives us 6x. And then when you differentiate the 4x, you're just going to get plus 4. So the second derivative is 6x plus 4. Again, I get it from around here. 6x plus 4. That's the second derivative, 6x plus 4. Now that the second derivative is 6x plus 4, all right, you need to find the derivative when x is 0 and x is negative 4 over 3. So let us do that. So when x is 0, at x being 0, when x is 0, the second derivative, I'm going to call the second derivative y double prime. Just to shorten it, y double prime means y differentiated twice. At x being 0, y double prime is equal to 4, which is greater than 0. And so what does that mean? That means we can tell them that. That means we can tell them that 1, x is 0, y is negative 1, 0, negative 1 is a minimum stationary point. So we can tell them that 0, negative 1 is a minimum stationary point. All right. Now the next one is at x being negative 4 over 3. At x equal negative 4 over 3, this one is going to be the maximum. At x being negative 4 over 3, we're going to see that the second derivative, y double prime, is going to be equal to 6 times negative 4 over 3 plus 4 is negative 4. So the second derivative is negative 4, which is less than 0. And so that is the local maximum. So we can tell them that, hence, we know that negative 4 over 3, comma 5 over 27 is the maximum stationary point. Nice and easy. Now it says now, differentiate y equal 2x times the square root of 4 minus 8x and simplify your answer. So let's work out part B together. So y is equal to this. Then I'm going to stop right dy by dx. I'm writing y prime. Y prime means the derivative of y. So y prime is equal to, keep the first times the derivative of the second. To differentiate the second, it's going to be carry down the power, which is a half. Then you subtract 1 from the power to get 4 minus 8x. And then a half minus 1 is minus a half. This becomes minus a half times the derivative inside this bracket, minus 8, plus, keep the second, and the second is just the square root of 4 minus 8x times the derivative of the first, which means it's multiplied by 2. And so what does that mean? That means that dy by dx is equal to, now, minus 8 times a half is minus 4. Minus 4 times 2x times a half is just x. X times minus 8. So that looks like minus 8x divided by the square root of 4 minus 8x. Plus 2 times the square root of 4 minus 8x. Nice and easy. And that's that. That's dy by dx simplified. No issues. So reach question 6 now. Question 6 is usually integration. And it says, show using integration that the finite area of the curve y equals sine x in the first quadrant is bounded by the line x equals 4 pi over 9 and is smaller than the finite region of cos x in the same quadrant and is bounded by the same line. Okay. So now let's go ahead and do this now. So show that the area of the finite region of the curve in the first quadrant bounded by the line, x being 4 pi by 9, is smaller than the finite region in the same quadrant bounded by the line. What does that mean? So I'm going to sketch the curve and show you. I'm going to sketch the sine graph just to show you typically what they're saying. The finite region in the sine graph looks like this. The sine graph starts from 0 and this is a sine graph. All right, this is how a sine graph looks. So the finite region is going to be from x being 0 to 4 pi by 9 is, this would be pi, And so 4 pi by 9, this is really 9 pi by 9. 4 pi by 9 is somewhere right here. All right, this is somewhere here. It's 4 pi by 9. All right, this is for a sine graph. So let me erase here just to make some space. All right, so that's what we want to find. We want to show that the area from here to here, this area, that area that I shade, this is for the sine graph. This is for sine x. We want to show that it is smaller than for the cos x. Cos x, this is the graph. Cos graph start from up here, so, and then go like this. All right, and so this is 0, and it goes to, let's put here as 4 pi by 9. And we want to show that the area for the cos graph is greater. All right, so this would be the region for the cos graph. So let's work it out now. So all we're working out then is call this area 1. Area 1 is equal to the integral from 0 to 4 pi by 9 of sine x. Now when we integrate sine, we get minus cos. So we integrate this, we get minus cos x. And we're integrating minus cos x from 0 to 4 pi by 9. So punch in 4 pi by 9, and we're going to get 4 pi over 9 in here. We get, let me put my calculator in radians. Let's get in the calculator in radians. And so we need 4 pi divided by 9. We need minus the cos of that. I get negative 0.17. This works out to be negative 0.17 minus, now when I put in 0, the cos of 0 is 1. So I get minus 1, minus 1 become plus 1. And so this works out to be 0.83. 0.83, and since it's area, I can say unit square. 0.83 unit square. So now I need to find the integral for the cos now. Let's call this one A2. A2 is going to be equal to the integral from 0 to 4 pi by 9 of cos x. Now when you integrate cos, you get sine. So what this works out to be is integrating cos, you get sine, and so you're getting to integrate sine x from 0 to 4 pi by 9. So let's put this in our calculators now, the sine of 4 pi by 9. And the sine of 4 pi by 9, this works out to be 0.98 units square. 0.98 units square. So see there? And so done. This one is indeed greater. So we can conclude, let's write a conclusion here. Since the area of A2 is greater than the area of A1, hence the statement above is true. Can't bother to write so much word. Hence the statement above is proven. All right. Can't bother write so much words, so this is just the conclusion. So we've proven that the area of the sine is smaller than the area of the cos in the first quadrant. Part B. Part B says the finite region of the first quadrant is bounded by the curve y equal x squared plus x plus 3. The x-axis and the line x being 4 is rotated around the x-axis. Find the volume generated. So to find volume, we have to remember that volume is pi times the integral of y squared dx. So the volume V is equal to pi times the integral of y squared, y is x squared plus x plus 3. All right, so volume is equal to pi times the integral of y squared dx, and we're integrating from, let me see, it says the x-axis and the line 4, so integrating from 0 to 4. All right, so first thing we need to work out what is x squared plus 3 all squared. So we need to work out what is x squared plus 3, x squared plus x plus 3 all squared. So we're going to work that out up here. What is x squared plus x plus 3 times itself? Working out all of this is x squared times x squared, x to the 4 plus x cubed plus 3x squared plus, now x times all of this is now plus x cubed plus x times x is x squared plus x times 3 is 3x plus 3 times x squared is 3x squared plus 3 times x plus 3 times 3 is 9. I know I write it all over the place, but don't worry, I'm going to group the like terms. X squared, x cubed here, and an x cubed here. All right, a 3x squared here, a x squared here, a x squared here, and then the x's and the 9. So what does that mean? This volume is equal to pi times the integral of, there's only one x to the 4 term, so it's x to the 4 plus this x cubed and this x cubed and this x cubed is 2x cubed plus, now the x squared term is 3x squared, and 3x squared is 6x squared plus x squared is 7x squared. Then I need my x terms, my 3x and my 3x is plus 6x plus 9. So that's what I'm integrating. And I'm integrating with respect to x. So put my dx. So now my volume is equal to pi times the integral of, so now add 1 to the power x to the 5, divide by the power of 5, plus add 1 to the power, which becomes 2x to the 4 over 4, plus add 1 to the power, that becomes 7x cubed over 3, plus add 1 to the power, that becomes 6x squared over 2, plus 9x all right? And of course, we're integrating from 0 to 4. Nice and easy. So this is going to work out to be, plug in x as 4 now, 4 raised to the 5th power over 5 plus 2 times 4, 2 times 4 raised to the 4th power divided by 4. Let me try to put all of this in the calculator one time. 4 raised to the 5th power over 5 plus, that look like 0.5 times 4 raised to the 4th power plus 7 over 3 times 4 cube plus 3 times 4 square plus 9 times 4. And I get 566. So this is 566 and 2 over 50. 566 and 2 over 50 units cube. Always remember volume is units cube. Units cubed, that's the volume. Nice and easy, soft. Now the next part of the question says, a curve which has gradient 3x minus 1 passes through 4, 1. Find the equation of the curve. All right. So now if dy by dx is 3x minus 1, then y is going to be equal to the integral of dy by dx. So y is the integral of 3x minus 1 dx. All right. Y is the integral of 3x minus 1 dx. So what does that mean? Y is equal to, add 1 to the power, so get 3x squared, divide by the power 2, minus, add 1 to the power x, plus constant c. Then now at the point A is 4, 1. So at 4, 1, at the point 4, 1, we're going to put y as 1 and x as 4. So at 4, 1, y is 1, and so we get 1 is equal to 3 times 4 squared over 2 minus 3 times 4 squared over 2 minus x is 4 plus c. All right, that's what we have. Nice and easy. So all we're required to do now is to find c. So let's find c now. So we transpose to find c, we're going to get 3 times 4 squared divided by 2 minus 4. That's 20. 1 minus 20. And so c equal to minus 19. And so the equation of the curve is then y is equal to 3x squared over 2 minus x minus 19. That is the equation of the curve. Nice and easy. Soft. Y is equal to 3x squared over 2 minus x minus 19. All right. That takes care of the integration part of the question. And now that we finish the integration part of the question, we're going to go to now statistics. Statistics and kinematics. Now question 6 deal with this integration. Question